Good day and welcome back. In this video, we're going to talk about the second topic in kinematics, which is the projectile motions. We are going to learn how to solve problems on projectile motions without the air resistance and also to explain the effects of air resistance on the motion of bodies in air. First of all, projectile motions is a motions of an object in the air under the influence of gravity. It can be considered as the extension of linear motions that we have learned in the last video. Recall back one of the questions discussed before this, which is from the trial paper of St. John Institution. Linear motion only involves motion of a straight line. Let's modify the situation here. We shall have the ball is moving to the right with the constant velocity of 10 meters per second, and it is rolling off from a building. So the ball will continue to move to the right, and it is also falling to the ground due to the gravity. So to solve these questions, we shall split our solutions into two components, which is the vertical component and the horizontal component. So the solution for the vertical components will be the same as in the last discussion, while for the horizontal components, the ball is moving in a constant velocity, so there will be only one applicable formula, which is the S is equal to Vt. So by using this formula and put in all the value given, you can calculate the horizontal displacement, also known as the range of the motions, and it will be equal to 16 meters in this case. Besides the range, there is also another variable can be expected in the questions, which is the final velocity. As I mentioned earlier, we have two components, so we need to identify the value of final velocity in each of the components. Remember that horizontal velocity is always constant, while in vertical components, apply the suitable linear motion equations as I have discussed in the last video to obtain the final vertical velocity, which is equal to negative 15.7 meters per second. So after we have both these informations, our next step is to perform the vector additions, and you should be familiar with the process. First is to apply the Pythagoras theorem to obtain the magnitude of the velocity, and then you can apply the trigonometry to obtain the directions of the velocity. So these are the two additional variables you can expect in the questions related to projectile motions. I will suggest you to do more exercises to master this topic, and I will use one example to discuss about this in a general. Let's look at this question, which is from the trial paper of SMJK Chung Confucian in 2022. The neutron is emitted from a generator of 4 degrees to the horizontal, and it needs to pass through the collimator and then enter the neutron detector, which is 100 meters away from the generator. So here we don't have the value of initial velocity. We shall focus on the collimator, which has a lot of information for us to solve the initial velocity. Before that, we shall resolve our initial velocity into two components. One is the u cos 4 theta as the horizontal component, and another one is the vertical component, and it is equal to u sine 4 degree. So let's see what we have from the diagram. At the collimator, we have both horizontal and the vertical displacement, which is 30 meters and 1.8 meters respectively. Let's solve it in the horizontal component. So do remember that we only have one applicable equation for motion with constant velocity, which is that S is equal to Vt. So put in all the value available, and we have the equations of 30 is equal to u cos 4 multiplied the time. And then for the vertical components, we have the value of s, u, and the accelerations, but we don't have the time or the final velocity. So here we have three unknown variables, which could be very complicated. So what we can do is to avoid one of the variables, which is the final vertical velocity, which is not included in the equations of the horizontal components. So we can use the formula of S is equal to ut plus half at squared. So here we have two unknown and two equations. So just do it simultaneously, apply the substitution method, and you can obtain the initial velocity is equal to 122 meters per second, and the time to reach the collimator is equal to 0.25 seconds. Next, let's shift our focus to the neutron detector. So now we have the initial velocity and the horizontal displacement. So we can solve the horizontal component first, and we can obtain the time to travel to the neutron detector is equal to 0.82 seconds. And then we can use the value of time to put it into one of the vertical component equations, such as the S is equal to ut plus half at squared. And here we can get the height of the neutron detector, which is equal to 3.68 meters. So there is one interesting question in this trial paper. Has the neutron achieved their maximum height in the trajectory within the 100-meter tunnel? And prove your statement. So there are a few ways to answer these questions. Now let's review back again about the maximum height. So do remember that the vertical velocity at this point is equal to 0. With these very important informations, we can find out something more about this. First is you can apply the formula of v squared equal to u squared plus 2as, and you can obtain the maximum height is equal to 3.69 meter. Another formula would be the v is equal to u plus at, and you can obtain the time to reach the maximum height is equal to 0.87 seconds. So from here, we can compare the time to reach the maximum height and the time to reach the neutron detector. The time to reach the neutron detector is 0.82 seconds, which is before the time to reach the maximum height. So we can say that the neutron did not achieve the maximum height in the trajectory. So another way is to find out the value of the horizontal displacement. We have the time to reach the maximum height is equal to 0.87 seconds. So put it into the formula of S is equal to Vt, and you can obtain that the range is equal to 106 meters, which is at the right of neutron detector. So in conclusions, we can conclude that the neutron did not achieve the maximum height. So after we know the actual path, we can do some correction on the diagram. So this will be the one you can expect, and I will leave it to you to check on it. So to conclude projectile motion, it is a motion of an object in the air under the influence of gravity. If we don't consider the air resistance, horizontal velocity of the object stays constant, while it is accelerating at 9.81 meters per second in the downward directions. In reality, there will be air resistance which will affect the projectile motions. Horizontally, there will be drag force that cause decelerations in the horizontal velocity. So the final range of the motion could be shorter than expected. So there is also drag force due to air resistance in vertical components, which cause the downward acceleration is lesser than 9.81 meters per second squared. So the time to reach the maximum height or the ground could be longer than expected. So one of the related example would be the terminal velocity, that the acceleration of the object will come to zero at a certain point and the velocity stay constant until it reaches the ground. So that's conclude my discussion for today. If you still have any question, leave it in the comment section below. Also, do leave a like and subscribe my channel. I will see you in my next video. Thank you.